We've spent the last few lessons looking over indicial equations and log laws, solving a range of them, and we've been working away a little bit over the last few lessons on practical applications, which generally include questions around growth and decay. So, increasing amounts of particular quantities and decreasing the amounts of particular quantities. Here's I thought we'd work through a couple of problems so that you've got some examples to work through, and you can hear about the thought process that goes around these questions, and then obviously you'll then hopefully be comfortable with doing a few more of these questions at a later stage. So let's have a look at a decay problem. And we know that the decay problem is because we have y equals y naught e to the minus 0.6t. Okay, so important to know that this is a decay function. You can probably, from the question here, it talks about changing a particular amount into something else. So changing that into another amount means that this particular gluconolactone reduces in any amount by this and using this particular equation. So first question, first part of this says find the value of y naught. So changing gluconolactone into gluconic acid can be modelled by the equation here, where y is the number of grams of the gluconolactone present t hours after the process has begun. Now we would obviously, in our heads, we're thinking to ourselves, well, at t equals 0 means just as the process is about to begin. Suppose 200 grams of gluconolactone is to be changed into gluconic acid. Find the value of y naught. Well, this one should be relatively easy. We should be able to simply say that y naught is equal to the 200 grams because that's our starting value. So far what we're doing is we're building our equation. Write the equation replacing y naught with your answer. So we will have now y equals y naught, which is the 200, e to the minus 0.6t. This is a fairly easy question, but something that worthwhile getting our head around. Okay, it says here how many grams of gluconolactone will be present after 1 hour. Give your answer correct to the nearest gram. So that's easy. After 1 hour, i.e. t equals 1 hour, y will be 200e to the minus 0.6 times 1. And if we get our graphics, our calculators out, let me just grab mine. Working that here on screen, we should be able to work out that 200 times e to the power of, and what we're going to do is we'll put it in brackets just to make sure that we know that's the case, and we end up with 109.8. I think they want it, 109.8 grams after 1 hour. Now it says here now for part D says how long will it take to reduce the amount of gluconolactone to 50 grams. So time is now unknown, but we do know that y is going to be, can we multiply when after y is going to be 50 grams. Now it won't be 150 because that's how much it has reduced by. The y actually represents what it actually is, so it'll be 50 grams. Okay, so if we put 50 into our equation, substitute 50 in for y, 200e to the 0.6t. What we can do is we can divide both sides by 200. So we'll do that, divide by 200 to try and get the t on its own somewhere along the way. So we're now down to a quarter equals e to the minus 0.6t. Right, and if I'm just going to scribble that out and put 0.25. Work in decimals a little bit better, and what we'll do is now we're knowing n equals a to the x over here, we can then swap that round and say x is equal to log a to the n. Alright, so that's one of those we can go back and forward there. So with this particular problem here, x is the negative 0.6t, we have equals log, and e is our base, and 0.25. Our next line, we're going to divide both sides by negative 0.6, and that becomes t equals, and log e we know is natural log there, of 0.25 over negative 0.6. and our value there of t. Let's do it on our graphics calculator here. We're going to have ln 0.25, that's equal to minus 1.386 divided by, what do we say, negative 0.6 divided by negative 0.6, and we end up with 2.31, and we're hours, and the question says how long will it take for the amount of gluconolactone to get to 50 grams? Give your answer to the nearest quarter of an hour. So we're 2.31 hours, so it'll be, you'd say the nearest would be 2.25 hours.